So guys, today we're gonna complete our course, second day, talking about second part of PMP, Principle and Procedure. So we're gonna talk about the kill sheet, killing method, ballooning effect, kick tolerance, gas hydrates, and drills or training being conducted in the well site to ensure the crew is effectively can recognize and deal with different situations. Okay, so now let's go ahead discussing with you the kill sheet and how to solve a proper kill sheet. First thing, okay, so let's so the kill sheet is like this one. We have data for the well. We have hole size, we have hole depth, TVD and MD. Our kill sheet in the exam will be TVD well, not directional well. So here casing TVD measure depth, then here drill pipe capacity with unit per feet, and heavy wall drill pipe length, then having its capacity, then drill cooler length, then its capacity, then drilling fluid density or the current mud weight, then the capacity for the open hole with the cooler, open hole with the drill pipe, heavy wall drill pipe, capacity between casing and the drill pipe, this one, and fracture fluid density, shut and drill pipe pressure, the recorded data after shutting the well, shut and drill pipe pressure, shut in casing pressure, bed gain, and here the pump data, pump displacement, and SCR pressure or pump pressure. So what is the purpose of pump displacement? This one is to convert your volume from parallel into stroke. And what is the purpose of the pump rate SPM, 30 SPM, is to calculate your time required. So we have number of strokes, and if we have number of strokes, we can divide over the pump rate 30 stroke per minute, so we can calculate the time in minutes. So now let's see the kill sheet. Here is the first page of the kill sheet. It's divided into sections as you see. First section here on the top left is formation data. So he may give you in the well data surface liquid pressure. If it is given surface liquid pressure like this one, then drilling fluid density as test. This one. So first thing, he need to calculate maximum allowable drilling fluid density, then to calculate initial mass. So let's share with you the whiteboard here. So first thing is to calculate the maximum allowable mud weight. We have three methods to calculate it. First thing, if he give us leak of test pressure, if he give us fracture pressure, if he give us fracture gradient, Okay, so if he gave us leak of test pressure, so we need to calculate the maximum allowable mud weight as full. Okay, first thing here is to put the mud weight at test plus leak of test pressure, as discussed yesterday, leak of test pressure over 0.052 times here the TVD of the show. Okay, this is the first thing. If he give us fracture pressure, so we need to take the whole fracture pressure and divide over the constant 0.052 times TVD show. Okay, if he give us fracture gradient, if you remember from yesterday, we have hydrostatic pressure gradient or pressure gradient equal what? Equal here mud weight times 0.052. So once he give us fracture gradient and asking for the maximum allowable mud weight, the equivalent mud weight, so we need here to take the gradient and divide over the constant. So here, take the gradient, fracture gradient, and divide over the constant 0.052. So now you get the maximum allowable mud weight. And as discussed yesterday, if the answer, for example, is, let's say, 15.32, so we need to make round down, so it will be 15.3. If it is 14.09, so we need to round down, so it will be 14 only. Okay, 14 ppg. That's for the maximum allowable mud weight. Second thing to calculate is the mass. Here, mass. Maximum allowable annular surface pressure. Maximum allowable annular surface pressure equal what? Equal fracture pressure minus hydrostatic pressure at show. Okay, so if we make the composition for the two factors here, so it will be maximum allowable mud weight, the one we just calculated, times TVD show times 0.052. That's for fracture pressure minus hydrostatic pressure will be drilling mud weight or current mud weight times TVD show times the constant 0.052. So we're gonna take common factor TVD constant. So now the mass will equal maximum allowable mud weight minus drilling mud weight, okay, times the constant 0.052 times the TVD show. And same thing, we're gonna make round down for this value as it is the maximum pressure, okay, maximum surface pressure. So if the answer is 1287.67, so we need to round down, ignore the decimal number, so it is only 1287. If it is 1356 point something 99, so we need to round down, so ignore the decimal number, so it will be 1356. Okay, that's all for the maximum allowable drilling mud weight and for the mass calculation. Now let's go ahead for volume calculation. Okay, so if we have our well like this, here is the drill pipe. Okay, so how here we have the whole TVD length, let's say 7,000, and the TVD length, this one for casing show is, let's say, 4,000. So the remaining part of the open hole is 3,000. Okay, if he give us the heavyweight drill pipe is, let's say, 700, and the drill cooler is, let's say, 800 feet. Okay, so let's make a hint here from the start. For volume calculation, we deal with measured depth. For pressure calculation, we deal with TVD. Okay, so first thing to calculate the volumes here, drill string volume, starting with the drill string volume. So starting here, first thing, drill string volume. It is divided into three categories. First one, drill pipe volume. Second one is heavy wall drill pipe volume. Third part is drill cooler volume. Okay, so let's talk for the first volume, this one, drill pipe volume. So guys, how to calculate the length of the drill pipe? We have the total TVD, we have the casing show TVD, we having the length of the heavy wall and the length of the drill hole. So how to calculate this length of drill pipe? Anyone could share? Length of drill pipe.
I think it's all drill string less than heavyweight, and then drill collar, and then bit.
Yeah, a bit has no length. It is ignored. So here to get this one, you need to take the measured depth of the well, 7,000, minus the heavy wall, minus the drill cooler. So it will be 7,000 minus 1,500. Okay, so it will be about 5,500. So here, 5,500. Lower measure depth of the well, minus heavy wall drill pipe length, minus drill cooler length. Okay, so any volume calculation equal what? Equal length of the thing times the capacity. Okay, and the capacity is given for all of these parts of the drill string and for the open hole and casing hole. So now drill pipe length, we got at 5,500. We need to times that with the drill pipe capacity. Okay, any number. So let's say the answer is 232.567. We need to just enough by 3 decimal. Okay, 3 decimal number. Okay, now the answer in parallel. Okay, for heavy wall drill pipe, we have its length 700 times capacity for the heavy wall drill pipe capacity. So let's say the answer is 81.3 decimal number 310. Okay, and drill cooler 800 times its capacity, drill cooler capacity. So let's say the answer, for example, is let's say 87.003. Okay, parallel. Here is parallel, here is parallel. Now to get the drill string volume, you need to make submission for all of these three parts. Okay, drill pipe, heavy wall, and drill cooler. So now drill string volume equal what? Equal the summation of all of these volumes. So let's say the answer is about 407.567. Okay, just enough with 3 decimal number. Now we have the drill string volume. Okay, it's okay. Okay, now go ahead to calculate the open hole volume and casing volume, the annulus volume. So annulus volume is annulus volume now is divided into two main parts. First part for open hole, then for closed hole. Okay, closed hole. Type. For the open hole, divided into two main sections for the drill cooler and for the heavy wall. Okay, so divided here for drill cooler with the open hole, and here section heavy wall drill pipe plus section drill pipe, remaining part of the drill pipe. So if we start with the drill cooler, we have its length 800. So take 800 times the capacity between this one, the capacity between the open hole and drill cooler. It is given. So here capacity between drill cooler and open hole. Okay, so let's say the answer is 101.313 parallel. And now for this section, guys, how to calculate this length from here to here, this length? Anyone could share? How to calculate the length of the heavy wall drill pipe plus this section from drill pipe? Okay, anyone could share?
The open hole minus drill color.
Yes. So here we have open hole equal 7,000 minus the casing show 4,000. So open hole is 3,000 minus 800 of drill cooler. So it will be 2,200, right? So now 2,200 times the capacity between open hole and heavy wall drill pipe plus section of the drill pipe. So let's say the answer is 151.311 parallel. Okay, and here to get the open hole volume, okay, open hole volume, you can make submission for this one plus this one, make submission. Okay, now go to the cased hole to calculate. We have here casing show depth is 4,000. So here it will be 4,000 times the capacity between casing and drill pipe. So let's say the answer is 213.40. Okay, parallel. Okay, now to get the total annulus volume is to make submission for the open hole volume plus the casing hole volume. Okay, then to get the whole well system volume is to make submission for the drill string volume plus open hole volume plus cased hole volume. Okay, now we have all volumes in parallel, but he asked for the volumes and the exam to be in stroke. You need volumes to be in stroke. So how to convert from parallel to stroke? By using, as mentioned, pump displacement. Pump displacement. If you look here again to the pump displacement, this one, pump displacement. Okay, so its unit, as you see, is parallel per stroke. So let's say we have our volume is any volume in parallel. Okay, any volume in parallel, and we need to convert it into a stroke. So we need to divide the volume in parallel over this number, pump displacement 0.1019 parallel per stroke. So now parallel goes parallel and stroke is here. Okay, so now we convert from parallel to stroke. So let's say if we have 400 parallel and we need to convert into strokes, so let's divide over 0.1019. So it will be here. Let's calculate. So it will be 400 over 0.1019. So it will be 3925. 3925.41. Okay, stroke. For stroke rounding, guys, for stroke rounding, you can round up or round down. It's okay. Both are okay. So this number may be 3925 only. So now round down, or it may be 3926. So you make round up. So again, for volumes, don't make round for the parts, like what, like here. Here, keep the volume in parallel. Take integral number and 3 decimal number. Integral and 3 decimal. Don't make round up or down. Keep it with the decimal number. Okay. Then for the final result for the real string volume, this one, after converting, let's say after conversion here, it will be 4007.5. Okay. So now you can make round up or round down. It's okay. Okay. But don't make round here to have accurate answer. Same thing for all volumes, okay? Don't make round for the volume until you convert it from parallel into strokes. Now you have options to round up or round down. Both are okay. Okay, another thing, if you need to calculate the time required for any volume to be pumped. For example, if he asking how much time you take to pump from surface to bed. So now you have the drill string volume, let's say for 007 stroke, okay? And we have our pump rate, 30 SPM, 30 stroke per minute. So now our volume in a stroke with stroke, now we can calculate the time. Let's calculate. So it will be, for example, for 407 over 30, it will be 133.56 minutes. It will be 133.56 minutes. So the time required to pump from surface to bed to pump this volume, okay, is 133.56 minutes. Clear, guys? Is it clear, guys? Hey guys, clear?
Could you repeat, please? I had the issues with my internet connection.
Okay, so we just talk about how to convert from parallel into strokes. Okay, you hear this point?
Yes.
Okay.
I stopped when we was started with the time required.
Okay, so now here time required. The time required for pumping any number of strokes. Let's say, for example, we need to calculate the time required to pump the drill string volume. So now we have our drill string volume is 4007. We can round up or down. So let's make round down. So it will be 4007. So here we have number of strokes 4007. So we need to calculate the time so you can divide. Yeah.
For the strokes, we have to run around the down.
Round up or down.
Round down.
Up or down. If you can make it 4008, it's okay. If you make it 4007, it's okay. In the exam, we have range. Let's mention plus 20 and minus 20. So this answer may be 427, 4027, and minus 20, for example, to be 387. Okay, we have range. So to be more accurate answer is to keep the volumes in parallel. Okay, just enough with 3 decimals. Then after make submission for the 3 parts like this one. Okay, then convert into stroke and round up or down, but don't keep any decimal number in stroke. Okay, keep it as integral number only.
Okay, also you said before in the capacity,
Yeah.
Drilling capacity 3 decimal, but here in IDC is written for 4 decimals.
Again, I mentioned for what? Here?
3 decimals in the capacity, drilling and the capacity, volume capacity.
It is not capacity, it is a volume, parallel.
No. I mean for the capacity before when he was calculating this the volume of annular.
So here I mentioned for 3 decimal for any capacity.
Yeah, 3 decimal.
No. For any capacity, you take the whole capacity. Let's back again to the presentation. You take the capacity as it. Okay, don't round. So here is 00492. You need to take it as it. Okay. Here for this one 00874. You need to take it as it. Don't round for the capacity. Capacity has no rounding.
So sometimes 100 number.
100 number.
But here is written 4. I don't know. Here is written 4. Okay.
The capacity you need to take it as it. Don't round, don't convert, don't make anything. Just so, for example, back again here. Okay. So here, for example, if the given capacity any number, let's say 0, 1, it's okay. If he given it 0.1, it's okay. If he given it 00173, it's okay. You need to take the capacity as it. Okay. Okay. So here for time required, you need to take the volume and strokes. For example, here 4007 and divide over the pump rate 30 SPM. Now stroke, go with stroke. Only we have a time. So now the time is 133.56 minutes. Okay, so clear here. Okay, so back again to here. What we do is calculating the maximum allowable drilling fluid density and make round down for this value. Okay, so for example, if it is 16.93, we make ignore for the 3, so it will be 16.9. Then calculating the initial mass. Okay, take this value here minus the current mode weight 14 times DVD show times the constant 0.052 and make round down for this value. So if it is 1489.9, we ignore this one, so it will be 1489 only. Okay, then coming to calculate here the volumes for drill pipe for drill string volume, we have 3 sections: the heavy wall given length, drill collar given length, and we calculating the drill pipe length, then times with the capacity of each section. Okay, then keep 3 decimal, 3 decimal, 3 decimal, okay, or 4 decimal, it's okay, but 3 decimal just okay. Then make submission for all of these numbers. So now we have the final result in parallel. Okay, then converting into strokes by dividing over the pump displacement, this value, pump displacement, parallel per stroke. Now we have the volume in stroke. If you make round down for this value, it's okay. If you make round down, it's okay. If you need to calculate the time, you can take this volume and divide over the pump rate and record here the time. For the annulus, we have open hole volume, so drill collar with the open hole, and heavy wall drill pipe and the drill pipe section with the open hole. Okay, then calculating the volume in parallel. For the casing section, same thing, take the TVD show times the capacity. So now we have the volume in parallel. If you need to convert into stroke, it's okay. Here it's okay. Total annulus volume equals the open hole volume plus the casing volume, this one. Total well system volume equals the drill string volume plus annulus volume. So if he asking what is the time required for one complete circulation, you need to take the whole volume, okay, all volume of the well drill string plus the annulus. Now here you have the total number of strokes, okay. Now you can convert into minutes, okay, calculate the time. Coming to the second page of our fill sheet, we have the recorded data, shot and drill pipe pressure, shot and casing pressure, and pit gain. So here for kill mode weight is to calculate is 14 ppg current mode weight plus shut and drill pipe pressure over the constant over the whole TVD. This one is whole TVD. Okay, at the time of the kick, whole TVD. Okay, for example, if the answer is 14.80, we need to keep the mod weight as mentioned, integral number, and 1 decimal number. So here, till mod weight, we need to have additional overbalance. So you're gonna make round up for this value. So it will be 14.9. If the mod weight is 15.01, so you need to keep it 15.1, and so on. Then here for initial circulating pressure, ICP equal dynamic pressure or SCR pressure, this one. For example, here at 30 SPM, we have pump pressure or dynamic pressure 650. So we're gonna use this pressure. Back again. So here equal SCR pressure or dynamic pressure plus shot and drill pipe pressure. Then for FCP equal kill mod over drilling mod weight, okay, times SCR pressure or pump pressure. And here we need to round up. So if the answer is 691.01, okay, we need to round up. So it will be 692 PSI. Why round up for the FCP? We're gonna discuss, but let's mention if we have our well like this, and here is drill pipe. Once reaching kill rate, so we have here ICP. Once pumping the whole string with the kill mod, so now we having here FCP. If the answer is 691.5, for example, the actual volume from calculation, and you make round down, so you keep it 691 only. So if you keep FCP at 691, you will be under balance with 0.5 PSI. So we need to round up. So we're gonna have overbalance. So here we need to keep 692 on the drill pipe, not 691. So you will be overbalanced, not under balance. Okay. Then here to calculate something called pressure drop. So you need to take ICP minus FCP, this one. Okay. So let's mention for this point. If we have, for example, like this, our drill pipe, and we're gonna pump kill mod weight. So if we start, let's go ahead with the whiteboard. Okay. Okay, so if we have our well like this, and here is the drill pipe, line up to the pump. Okay, so let's say we're gonna start to pump kill mod inside the well. Once kill mod reached, once pumping reaching kill rate 30 SPM, for example, so we have here on drill pipe gauge ICP value, let's say equal 900. Once we pumping the kill mod weight inside the well, so the drill pipe pressure started to decrease till reaching here FCP once reaching to the bed. So let's say equal here 400. Okay, so the pressure dropped from 900 to 400. So we need to calculate something called the pressure drop. How much is the pressure drop when pumping any number of strokes into the drill pipe? As we pumping the whole drill string capacity, the pressure dropped from 900 to 400, so dropped by 500. So if he asking for any number, let's say the drill string capacity is 800 stroke. Okay, so if we pumping 1 stroke, 2 strokes, 50 stroke, 100 stroke, 200 stroke, how much pressure will be dropped? So first thing, you need to calculate pressure drop per 1 stroke. So how to get it? Take ICP minus FCP over the real string volume in strokes. This one, 800, okay, in strokes. So for this example, let's say ICB 900 minus FCB 400 over 800. So zeros, zeros, zeros. So it will be 5 over 8. Let's calculate. So it will be 0.625. 0.625 PSI for each one stroke. So after pumping one stroke here, the pressure will be dropped 0.625. So it will be, for example, 899.3, right? 396. 375. 375. Okay, this number after pumping one stroke. After pumping two strokes, you need to multiply 2 by this number. After pumping 100 stroke, and this number is common. So for example, after pumping 100 stroke, you need to take ICP minus FCB over the real string volume. So you get the pressure drop for one stroke, then here times 100. So you get for 100 stroke. So let's say for 100 stroke, it will be 900 minus 400 over 800, the real string volume, times 100. So now you get the pressure drop for pumping 100. So if you pumping here 100 stroke, the pressure will be dropped by 6, let's say 0.0625 times 100. So it will be 62.5. Okay, 62.5 PSI for each 100 stroke. Okay, but this value need to be rounded down, so it will be 62 PSI per 100 stroke. If you keep it as it's okay. If you make round down, so it's okay also. Okay, guys, clear? Clear, guys? Guys, is it clear? Hey guys, is it clear?
So if you keep the decimal value, is correct also or no?
Yeah, is it correct? Yes, but if you round down, it's more easier to handle the whole calculation, as if we're gonna use this factor for weight and weight method. So for weight and weight method, we need to make step down table like this. Here is number of strokes, and here is drill pipe pressure. So we need to keep drill pipe pressure as integral number, not to have decimal number. Okay. So once round down, we add over balance. So it's okay. Let's say if we have the accurate value, the calculated value, once the pumping is 62.5. Okay. So 62.5 is the actual value. If we make round down for it, so it will be 62. So let's see the drill pipe pressure. It will be 900 minus 62.5. Let's make it 900 minus 62.5. So it will be, the actual one is 837.5. This is the actual value. But once round down, we're gonna keep the drill pipe at 838. So now we have overbalance of 0.5 PSI. So it is preferable to make round down for this value. Okay.
So also one question: if we get, for example, for Kilmad or something, we get only one decimal value. So
one decimal number.
One decimal.
Yeah.
We can take it as it is.
Yeah, but I think it's never happened, but it's okay. For example, if you calculate Kilmad weight, and it will be 15.1. Good.
We can take it like that, no problem.
Yeah, if it's only one decimal, yeah. But okay, it will be, for example, 15.101 or 10001. So we need to round up. So it will be 15.2.
0.2. Okay.
Okay.
Okay. Thank you.
Another thing for here for pressure drop, he may asking for pressure drop per 1/10. So what is the meaning of 1/10? He divided the drill string volume into 10 equally sections. And he asking for each section of these 10 sections after pumping in the drill string, how much pressure will drop. So now you need to take ICP minus FCP over 10. Okay, and then make round down if you want. So here it will be 900 minus 400, so it will be 500 over 10, so it will be 50 psi. So if we divided the drill string into 10 equal sections and pumping one section from these 10 sections, so the pressure will drop by 50 psi. Okay, clear, guys?
Okay.
Okay, so now I think we just finished the cal sheet. Okay, first page and second page. So now let's have a practice, guys. So please open your exercise book, section number 9. Start solving the first cal sheet. I'll give you 15 minutes to solve, then get back to check answer with. So open section 9, well data number 1. First cal sheet.
Sorry, I didn't get you because I have
Okay.
slow internet.
Okay. We need to have a practice. We need to have a practice on the cal sheet. So please open your exercise book, section number 9, cal sheet number 1. Start solving. I'll give you 15 minutes to solve, then get back to you to check answer with you. Okay.
Section 9. Okay.
So open section 9. Well data number 1 or cal sheet.